Okay, so natural log n over 13 n to the p, we need to know whether it converges. Um, we need to state the values of p for which it converges. So it looks kind of like a p series, right? 1 over n does not converge, but 1 over n to the 1.1 converges. 1 over n to the 2 converges. So it's tempting just to say p needs to be greater than 2. But we should double check. We need to compare it directly to 1 over n to the 1.01 power, as long as we can say that this is smaller than this, because the higher the power, the smaller the fraction, right? We need to be able to directly compare it before we can say whether it converges for sure or not. So the pesky thing is this natural log n in the numerator. So if you try out some numbers, natural log 2 is 0.693, blah, blah, blah. Natural log 3, natural log 4. So the numerator, it always takes whatever n is and it shrinks it because it's a logarithm. So one thing we can say right off the bat is that this is always smaller than n over 13 n to the p, right? Because n, like we start off with n equals 2, 2 is bigger than natural log 2. So this expression is always bigger than this expression. And then we know that this, through algebra, is equivalent to this. Okay. And so now we're looking like a p series, right? We can say that this expression is always smaller than this expression. So in order for this to be a p series, p needs to be something greater than 2. That way we get the 1.01 power. That's the minimum, or 1.001. So it was what our intuition told us at the beginning, but we need to do the algebra to make sure, because sometimes, calculus gets weird and we gotta follow the rules closely.